Hey guys, welcome to my channel once again. So as we know right now we are learning Python 3. So let's start with some revision of what we learned in lesson 1. Revision. We learned about variables. Variables are like containers that contain all the data in a program. They can be modified, and these are a few examples of variables. This is a constant variable as it will never change, and these are written in caps lock. And data types. So these are the data types. Data types are stored in variables. Strings are letters or numbers. They always have to be followed by inverted commas or quotation marks. Integers are numbers, whole numbers. Floats are decimal numbers, and these can be used for if we have to store prices or conversion rates. And booleans are true or false. Type and parenthesis is used to identify the type of a variable. Prints the basic output statement, and it prints whatever whatever data variables have or whatever function or module we are using its output. Name. Inputs basic is a basic input statement, so the person can input their name in this case and the basic operations. So let's run this. So the first one is string, the second is integer, third is float, and the fourth is boolean. And inputs are always string and string data type, and we have to be sure that we write type like this only, or print like this only, or input like this only, because Python is a case sensitive language. So now we can come to our lesson. Lesson 2. Second lesson. What are we going to learn in this lesson? Some more operations, input and output statements, and a few more data types. Let's start learning. So data types. Some more data types are comments. These are lines to describe a program. None, binary, octet, and hexadecimal numbers. And we will also learn how to convert data types into each other. So this is an integer, float, string, binary, octet, and hexadecimal number conversion modules or functions. For example, this is a comment, this is a none type, so this stores that nothing is in the variable. This is a binary number. Now this is in the string format because if we have to convert this into integers, it has to be a string only. But if you do this, then your program will not work. So now you can do single or double quotation marks, but they have to be the similar quotation marks on both the sides. So you can't do this, as this would still be considered a string continuation. So always use only one type of these. So this is an octet number, which is a system based on 8. Hexadecimal numbers are based on system of 16. And these we have already know: float, integer, and string. So let's convert binary into integer. So we write integer and we write our variable or the number here, and we have to write 2 in order to convert this. And this is for octane numbers, we have to write 8 in this case, and for hexadecimal numbers we have to write 16. We can also convert strings into integers, and we can convert floats into integers, but integers cannot be converted. I think so integers cannot be converted into floats, but let's just do it and see. So let's put float and let's see 12 and close it. Now I've got the basic output statement here, so I will run it. Oh, I forgot the parenthesis, so let's run this now. And oh yeah, so we will have to put this in our owner console, as I have got a minor setback on this one. So let's just paste in the owner console and do it. So okay, floats, so integers can be converted into floats, but let's see if floats can be converted into integers. Let's see. They can be converted, and now we know that the binary number was 114, the octane number was 15, and the hexadecimal number was 450. So this is just a side note, but hexadecimal numbers are mostly used to take color codes. So now let's get on. So these are the basic operations that we learned last class, and these arithmetic operations are the same as basic operations. So assignment operations are like what we use to assign a variable things. So like equal to, plus equal to, minus equal to, multiply equal to, divide equal to, modulo equal to, power equal to, and this is floor division equal to. So these are used to assign values and can do arithmetic operations too. For example, this is a simple assignment, this is an assignment, this is an assignment, and this is an assignment. Now we can print Z, and we can also write this, or we can also write this as this. So what it does is that it assigns Z what the value would be x plus Z, as we can see here. And the similar with all the other operations, I have done them all here, as you can see. This is subtraction, multiplication, division, and power. No, this is modulus. If you have missed the last lesson, then please watch it, but modulus is something that just takes out the remainder of a division. And we have got power, and we have got floor division. So also one more thing about assignments, more than one values can be assigned in a single line. Like if A and B are both 1, then we can write A is equal to B is equal to 1, and we can also do A is equal to 2 while B is equal to 1, but for that we will have to use a semicolon between both of them. And we can also do like this. So A is equal to 1 while B is equal to 2. So this is a unary minus operator. So whatever the value of a number is, it brings that in the subtractive form, like in the minus form. Let's check this in our owner console. This is not that. So let's do this and run this. So when we add, we get a 10, subtract 8, multiply 16, divide 8, modulus 0, power 0, floor 0, and 1, 1, 2, 1, 1, 2, and the minus operator. So let's go to this. Now back. One extra thing that you should know is that if you do A is equal to 1, print it, and then A is equal to 2 and then again print it, then the first thing would be 1 and then a 2. So you can update a single variable and you can print it at each step to see how it happens. And this is a very good thing too. So now these are relational ones. These are used to compare variables. To show this, we will use a if statement, which is a Python control statement which we will learn in further lessons. If you already know a language like Java or C++, you already might be knowing what it does. So like if we do like A is equal to, or if A is equal to C, then print no, then print yes. If it is no, then it would print no. So in this case, it would be a yes. If we do it B, then it would be a no, as A is greater than B, and this is on, so it would come no. So these are now logical operators. These are and, or, and not. So like if we have to check multiple statements and then we can use this, like if we want, if x is greater, if y is greater than x and y is smaller than z, then it would print yes. If we change it to or, then let's see what will happen. Let's just, oh, we can run this actually, and we get a yes, because one of them is true, but if we do it, if y is z, then if we do it, then it also prints a yes, as one of them is correct, one of the statements. And if we do if x is greater than y, and save it and wait, it will stay printing yes. Okay, that I have to work out why it will stay printing yes, even that should be a no according to me, but let's just go on. So these are a few more of the operators, but we won't be using these much. So this is Boolean one, and they work the same way as the logical operators, except, yeah, they are the same. Yeah. Bitwise, these are used on binary numbers. These are membership ones, so like we can see if something is a member of another thing. Identity, like it is equal to the equal to sign. Like if this is this, then do something. So print statement. So this is an output statement that we know. So we can print strings like this. We can print variables like this. We can print objects. We can also print strings and variables just by using a comma in between or using a plus symbol, but mostly the comma works, and then there are the formatted strings. So this is the input statement, and we can convert the string before it comes to the variable by using the integer or float module. So yeah, let me just say for practice you can ask the user for 3 variables and then use arithmetic, rational, logical operations and print them, and you can convert them into binary, octet or hexadecimal numbers. So that's it for our class today. Please like, subscribe and share this video. Bye and see you in our next class.